Today we are talking about polar coordinates. What are polar coordinates? The polar coordinate plane is an alternate way of graphing. Polar coordinates are in the order r and theta, where r represents a directed distance from the origin O to a point P, and theta represents a directed angle counterclockwise from the axis to segment OP. Real-life applications. From a physicist's point of view, polar coordinates, r and theta, are useful in calculating the equations of motion from a lot of mechanical systems. Besides mechanical systems, you can employ polar coordinates and extend it into a 3D spherical coordinate. This will help a lot in doing calculations on fields, example, electric fields, magnetic fields, and temperature fields. Polar equation graphs in real life. On the left, there is a rose curve graph with 8 petals, and the real-life example is a flower with 8 petals.
The formulas we use for polar coordinates are shown below. There's a typo with the so part of it, so just match cosine with cosine and sine with sine. But sine of theta equals y over r, so y equals r times sine of theta, and cosine of theta equals x over r, so x equals r times cosine of theta. Also, tangent of theta equals y over x, and r squared equals x squared plus y squared. When we plot points using polar coordinates, it's shown the way we described below. The point we plotted is 4 pi over 4, and there's multiple ways that you can write this point. We did negative 4, 5 pi over 4, which the negative just shows that it's directly across the graph, and the second alternate way of writing it is the negative 7 pi over 4.
Okay, when we convert polar coordinates into rectangular form, you take the coordinate, which is 2 pi over 4 in this example, and the 2 represents the r, or the radius, and then the pi over 4 represents theta, or the angle. And you would plug that into the x equals r cosine of theta, and y equals r sine of theta. And so you would put x equals 2 cosine pi over 4, and y equals sine pi over 4. So then you would take the cosine of pi over 4 and multiply that by 2 to get your x coordinate. And you would take sine pi over 4 times 2 to get your y coordinate. And so you would get square root of 2 as your point. And then you would do the same thing for the negative 1, 5 pi over 6. And then when you convert rectangular coordinates into polar form, you would use the r squared equals x squared plus y squared formula. And so you would do r squared equals 2 squared plus 2 squared, and you would get r equals the square root of 8, which equals 2 square root of 2. And then you would take the point 2, 2, and use the tangent of theta equals y over x formula, and so you do tangent of theta equals 2 over 2, which is 1, and so theta is pi over 4. So then you would put that into the coordinate r theta, and so you would get 2 square root of 2 and pi over 4.
Converting rectangular equations into polar form. You change the y to r sine of theta, and you change x to r cosine of theta. Then you divide by r cosine of theta, and it cancels out the cosines, and that cancels out r, and you're left with sine over cosine, which is tangent, so the answer is tangent of theta equals 3.
And then when you convert polar equations into rectangular form, you have theta equals 4 pi over 3, and so you would take the tangent of theta equals the tangent of 4 pi over 3, and because the tangent of theta equals y over x, you would change the tangent of theta to equal y over x, and so then you would take the tangent of 4 pi over 3, which is the square root of 3, so then you do cross multiplication, and you would get y equals x square root of 3.
For the second example, first you would multiply each side by 1 minus sine of theta, so you would end up with r minus sine of theta equals 5, and then you use the formula to make it r minus y equals 5, add the y over, and then you're left with well, then you square both sides with r squared equals y plus 5 squared, and then use another formula to change the r squared into x squared plus y squared. And so you're left with x squared plus y squared equals y squared plus 10y plus 25. And then you move that all over to one side and set it equal to 0, and that's your answer.